Okay, I think we can get started. Let's get started. Okay, okay, yeah. Thanks for everyone coming to this session talk. My name is Yong Tang. I'm a maintainer of CoreDNS project. This is John Belamaric. He is also a CoreDNS project maintainer as well. By the way, just to briefly introduce John, he is also author of a couple of books, and one of the books is about the introduction learning CoreDNS, and this book is currently in preview. So if you have any interest, you can browse through the book online. Yeah.
Yeah, you can see a couple of chapters are available.
Yeah. That's a good thing. Yeah. For today's agenda, we are going to go through several things. First, we're going to give a brief introduction on CoreDNS. I think a lot of people may already familiar, but just for completeness, we'll list several points for CoreDNS. We're also going to provide a brief status update for various plugins. We are going to discuss about Google Summer Code. And finally, we'll go into the technical deep dive, which John will spend a lot of time talking about the integration of Kubernetes with CoreDNS. And also, at the end, we'll try to see if we can demo a plugin, if time permits. Let's just briefly introduce CoreDNS. CoreDNS is a flexible DNS server written in Go. It has a focus on service discovery. CoreDNS is plugin based, which means it's very flexible and it could easily be extended for external and additional functionalities. At the moment, CoreDNS is a default DNS server. I think we get into Kubernetes in 1.11, and we reach a status of default in 1.13. CoreDNS itself supports DNS over TOS, and DNS over gRPC. The DNS over gRPC, by the way, is a customized implementation. However, it's very useful and a very nice feature. It's a very good fit for cloud-native applications. CoreDNS also have Route 53 DNS sync up, which allows you to sync up your Kubernetes cluster with AWS Route 53 service. And finally, CoreDNS is started and led by Mick Gibbon. He is very energetic, and he spends most of the time on GitHub. So I'm sure everyone can see him, if you want to find him. I'm going to discuss about some of the community updates for the past year. So first of all, we have 148 contributors at the moment. So big thanks to anyone that contribute to CoreDNS. We have 16 maintainers. We have 29 public adopters. The adopter list it's actually a public adopter list, which means we only list those users that are willing to allow us to use a name. So I'm sure there are a lot more users, especially in Kubernetes community. And finally, we have a lot more GitHub starts compared with last year. Actually, like a couple less than 4,000 starts. That's a big achievement. By the way, if anyone has not started CoreDNS yet, you probably can just push the button now. For CoreDNS community, if you want to find help, you can always find help from GitHub. That's the most active one. Slack channel is another one that's very active. I think John is on Slack channel most of the time. We have other resources on website. We have a blog. We have Twitter. The Google group is not very actively maintained, so that's not some place if you want to search for help. One thing I want to mention is that thanks from Google, we actually participate in Google Summer Code 3 years in a row. In 2007, Vayu, he contributed DNS tab. In 2018, Jiacheng, he contributed to integration of CoreDNS with etcd, and this year we also have a proposal accepted. So that's a big achievement. Hopefully we can continue the trend moving forward. Now, I'm going to switch my microphone to John. He is going to go into the deep dive of Kubernetes, CoreDNS. He will discuss about updates for Kubernetes, discuss about how queries are resolved in CoreDNS, and finally, if time permit, he will try to show a plugin that you can write in less than 100 lines of code.
Great. All right, thank you. Well, thank you everybody for being here. I'm always a little surprised so many people show up to talk about DNS, but glad you're all here. I'd like to leave a lot of time for questions at the end. In the past with these deep dives, we've had a lot of questions. Hopefully it'll be the same today. But talk a little bit about changes really in CoreDNS that have happened since it became the default in Kubernetes. So today, or in 1.13, it became the default, but really it went GA as far as being generally available in 1.11. And we're still using the same version. Maybe there's a point release update or something since then, just a patch release. And the reason is, even though we've made a lot of changes in CoreDNS, the Kubernetes deprecation policies are such that we need to sort of give enough notice before we make changes to the configuration file. Some of the newer versions have some backward incompatible changes. So we want to give enough time, and we want to come up with a tool that will help people migrate. Very minor changes, but just things that have to be tweaked. In any case, in the last KubeCon, we talked a lot about CoreDNS in Kubernetes and went into a lot of detail. We didn't have a talk on that this time, but I at least wanted to take some time to talk about some of the new things. One of the things that's available if you do update to the newer version of CoreDNS is this new plugin called K8s External. So we had the Kubernetes DNS service discovery specification, which is what the Kubernetes plugin implements, is really just for internal cluster DNS. But of course, if you're exposing your services with load balancers, with a load balancer or with external IPs, it'd be nice to be able to have a way to publish those externally as well. There's a project called External DNS that can do this pretty flexibly, but for really simple use cases, instead of having to run a whole other controller and do all of that, we added this K8s External. You enable this plugin, and it will allow you to basically create another zone that contains any load balancer services or external services with external IPs. It'll allow you to publish those under that domain. So it still follows a very specific schema. There's not annotations to make it into whatever sort of name you want, but at least lets you expose those, like say internally in to the rest of your organization. And in fact, you can even in your corporate DNS, you can delegate that zone to this DNS instance. If you do this, though, it's probably a best practice to run a separate instance of CoreDNS to do this, just so that you don't let anybody from the outside wedge your DNS, cluster DNS, just for safety. Other interesting changes, the core file you have in an existing Kubernetes cluster will use something called the proxy plugin. We deprecated that, removed it, and replaced it with something called forward. Pretty much it's just more efficient. Proxy would open a new connection, basically, for every single request that came in, and now we share the same socket basically across requests, and it runs a lot faster. Health plugin changed to health and readiness plugins separate. So, just a little improvement in the way that we manage, knowing that the API server is synced fully to CoreDNS before we start serving traffic for it. Probably the only other incompatible change is we pulled out the upstream option. This is kind of like a small detail, but that's one of the things you would have to change in your core file if you were to upgrade. You have to just take that option out. The default behavior now is to do what it did the way it was configured before. I forgot, I had a slide actually specifically on the backward incompatible changes. So these are the kind of changes, and of course, these slides are available. It's probably easier than me going through them one by one. So since we didn't have the talk on CoreDNS in general, I did at least want to help people understand how CoreDNS resolves a query. So when you go and look at the core file, so a core file is our configuration file. It consists of a number of stanzas, and each stanza starts with, can you see the cursor on there? Yeah. Starts with a domain and a port. And typically, it'll all be the same port because you only want to serve things on one port. All these get gathered up, but queries get routed through these plugin chains. So each stanza defines a set of plugins or operations that you want to do on the request. And so you can have a different set of operations based upon the zone of the query. So in this particular example, what we're showing is that we have organization.com runs through the errors and cache plugin with a high TTL of 3600. And the on-prem.organization.com runs through those same plugins, but it reduces the maximum time we keep something in the cache to 300 seconds, and it also forwards to a different upstream server. Whereas any other domain, so any other domain will go through this other set of plugins, in particular to Kubernetes for cluster.local, and then out to the internet or wherever it may be. So I guess now, if it looks like we do have time, we have plenty of time, we can talk a little bit about how to build a plugin. So what we'll talk about here is how to build this is just a simple demo plugin. It's available on our GitHub as well. It's a stupid plugin. You wouldn't really want to do this. But essentially, any request coming in here will return quad 1 for a certain set of CIDRs based on the source IP, and returns quad 8 otherwise. So it's really simple to make a plugin. It's really just 3 functions. Typically, we put them in 2 files. We have a setup file. The setup file just has this init function. That init function registers the plugin with caddy. So one of the kind of strange things about CoreDNS is that we use this web server framework called caddy. So it's a Go-based web server that was built by Matt Holt, I don't know, years ago. And when we initially did CoreDNS, or when Meek did it, he liked that plugin or middleware type of model, and so he said, well, I'll just fork that and start building it. And so he built this CoreDNS server on that forked caddy, and then we said, well, that's sucky to fork it, so we actually backed that out and pulled it in as a library and worked with Matt to make it into actually more of a general server framework. So all of the basic server lifecycle management, the parsing of the configuration file, the creation of the server, the response to signals to reload your configuration file, graceful reloads, all of that stuff we got for free out of caddy, and we just had to implement, more or less the specific DNS logic. But
that's amazing, because Mickey essentially just grab a HTTP server and convert it into a DNS server.
Yeah, which is surprising. They're pretty different protocols. But what that means is that you'll see, if you're writing plugins, you're interfacing with some of the caddy libraries, and in particular around parsing of the configuration file. So that's why we say we register it with caddy. We're registering that function. Essentially, each of these plugins corresponds to a directive in the file. So if you wanted to create this one called demo, your init method basically just says, associate the directive demo with this setup method. And then the setup method gets passed this controller, which is a pointer into the configuration file, more or less, and you parse it from there and do whatever you need to do. And then lastly, typically in a separate file, where you'll implement your serve DNS method, and that actually does the handling of the DNS request and does whatever you need to do. We can actually look, like Yong said, this is very few lines of code to do this kind of thing. You can see the init plugin is essentially one function call, or the init call, And demo just consumes the tokens out of the configuration file and adds the plugin to what's called the plugin chain. So like we saw in the way that the queries are resolved, you have these different paths that the query can go through. Each of those paths corresponds to a series of plugins that call one another. In essence, they pass the request down. They say, if I didn't handle this request, I need to pass the request down to the next plugin to handle it. And so that's essentially registering with that chain. The serve DNS method itself receives a context, what we call a response writer, and the actual DNS query, the DNS message. And the response writer is really just an interface that, in the sort of basic case, will be just a socket that you write back to the client. But we have a little tricks we do in order to let plugins do more sophisticated things, where, for example, we have something called a non-writer response writer, so that if any downstream plugin, one plugin can wrap that response writer when they call the next one, and then any of those downstream ones, when they write the packet, it just gets stored in memory. The one that wrapped it then can unwrap it and play with it and do what it wants and send it back to the client. In any case, in our simple demo plugin, all we do is look at the source IP. That's what this state.ip does. And based on its first octet, we set the reply address and log it for good measure. And from there, we just return the packet. In order to get that to work, you need to rebuild, of course. And, well, not of course, actually. Let me go back on that. Go, until recently, was pretty much completely statically compiled. So you didn't have any way to do dynamically loaded modules. You can now in Go, but a downside to using Caddy is that it handles all of that for us, and they have not moved to the newer Go plugin method. So without going and doing that for Caddy, it's kind of a pain for us to make it happen. So we still live with statically compiled plugins. So anytime you create a plugin, you have to build a new version of CoreDNS. It's not hard to do, but it's a little less convenient. In any case, though, once you do, then this core file would work. It would read the demo, and it wouldn't puke on it, and you'd go ahead and I don't know if you have this actually working somewhere and you want to run it, but building it, this shows you how to build it with Docker. We have a Docker, it's much simpler to just use the Golang Docker image if you don't have a Go environment set up already. Do you want to show the demo? Or? Sure.
Yeah, I can certainly show how to build the demo plugin, and it's quite straightforward. So essentially, I already have a CoreDNS repo. So that's actually cloned from GitHub. As you can see, I only modify one file, plugin.config. I also add a couple of files.
Yeah, the plugin.cfg, so essentially the way that CoreDNS decides what plugins to compile in is this plugin.cfg, and then there's a go generate call that will actually build a Go file that pulls in all those plugins. And so you can disable plugins as needed and rebuild to make it smaller, like with later today there's this node local DNS cache for Kubernetes talk you may want to go to, 445. That actually uses CoreDNS internally for the node local cache, and what they've done is essentially only loaded in a couple of plugins that they need. So that makes it really tiny, and so you know less than 10 megabytes, which you want if you're putting out at every single node.
Okay, of course, the next step is to just build the CoreDNS. As we mentioned, if you already have Docker installed, that's going to save you a lot of effort to try to configure Go environment. By the way, if you take a look at the plugin/demo directory, there are only 2 files, and all the content we from the slides. So that's actually less than 50 lines of code. So I think that's going to be easy enough. It's going to take probably like less than a minute to complete the build process, but that should be it.
So recently we moved CoreDNS to using Go modules. So what that means for those Go developers in the crowd is that you no longer need to put it under your Go path. You just can build it in any directory, and it's much nicer than it used to be. But that's what we're seeing is it's pulling down all the things that are in the Go module. When that's done, Yong can show you that, but maybe, I don't know how long it's going to take, so we could start opening it up to questions. I think we have about 10 minutes left, so that's probably, yes, sir? Yeah, can you, because they're recording, then people will hear it.
Hi, so if I want to write a plugin with a special configuration to participate, like have my own configuration for my plugin, how difficult or easy is it? I want to write a plugin with a special configuration and write it in the same core file, for example.
So yeah, that's what you'll do in that setup function. So the setup function will, if your configuration violates the caddy syntax, you might have some trouble, but if you're making it up and you can do it however you want, keep it within the caddy syntax, which is pretty flexible. And then you'll just, in your setup function, it tokenizes it for you, and you just put in whatever config you want, and you do it however you want. So if you look at some of the examples, this one only has one thing, so it's not that rich, but look at some of the examples, you'll see how we do that. Yes? You want to? Well, I have to say, you guys, we didn't, last time we gave shirts away to people who asked questions. Maybe that's why we got so many, but we don't have any shirts today, I'm sorry to say.
Do you have any shirts? So the question is, can I use CoreDNS to point to a Route 53 DNS server?
Yes, and in multiple ways. So CoreDNS can upstream to any DNS server, but in fact, we have a plugin that will read the Route 53 API and serve those records up directly. So you can do that in order to not have to go to the Route 53 DNS servers. Okay. Any other questions? I feel like Phil Donahue, you know, I'm going through the... There you go. I guess I show my age when I say that.
Right. So I wanted to ask, like, about the next steps. Once you have the plugin written, how about upstreaming it? Because there's the third-party plugins, and I wonder if there's like some official guidelines what should go into the third-party ones, or what can go to the main repo.
That's a great question. What was your name? Sorry. Antonio. What Antonio here is talking about is on our website we have plugins, and we have external plugins, we call them. So plugins are the ones that are built in by default. So they're in that default plugin CFG. And then other people who've written plugins that do other stuff, or even members of our community who are, like even Meek has written some external plugins that use Redis for a cache, for example, that may not be as useful for everybody, so we don't build them in by default, just to keep the binary from not getting too big. But the question was, how do we know what we can upstream? How do we know what should stay external? The first part, or the first part, what do we know what to upstream? It really just comes down to, do we think it's pretty widely useful, and is it not too complicated? Does it not bring in tons and tons of dependencies? Like Kubernetes brings in a ridiculous amount of dependencies, but it's really, really useful for one of our main use cases, so it's there. Many other things we wouldn't bring in if they brought in too many dependencies. So in that case, though, it's so easy to, if you have an external plugin and it's on your GitHub or wherever, then as long as it's accessible by Git, you can add it to our website in the external plugins. And in that plugin CFG, we didn't show it here, but basically it consists of directive : go package name. And so that Go package name can be anywhere. It doesn't have to be in the CoreDNS organization. So I guess the short answer is put it in GitHub, and you can get it on our main website. If you want it built in, make sure it's really useful to everybody, and you have good documentation. Yes. Thank you. Michael Grosser here is another one of our contributors and maintainers, so he's helping out.
Is there any plan that there's some mechanism that you don't have to build it inside? As I mean, it's really looking a lot like Terraform providers that for a long time they were part of Terraform until that was completely unmanageable. So it's better to maintain the life cycle of a plugin if it's a different binary.
Yeah, I mean, that would be ideal if we had something like the Go plugin that's dynamically loaded. But like I said, unless we were to break from Caddy, which would be an enormous undertaking, or we implement it for Caddy, like right now they're not using Go plugins. So what they do, which is interesting and we could consider doing, is on their website you can actually go in and if there's 50 different plugins, you can check a box and push a button, and it'll go build it for you and give you the binary. I don't really like doing that because it makes it so you can't like create an image that you just put on GCR or something and everybody can use. It's not great. So right now we're just a little bit stuck where we are,
Okay.
but it would be ideal to have a process like that. Yeah.
Thank you.
Wow, it's still running.
I'm actually having some trouble with that. I know because I didn't pray for the God.
The demo gods, yeah. So you didn't sacrifice anything. You sacrificed a MacBook then. All right, any other questions there? I think we have 4 minutes left, so if there are other questions, happy to answer them.
So on the note before, so because we moved to Go modules, it's much easier. It's basically you pull in the CoreDNS library or sort of as a library. So you basically have your setup function, and then that one pulls in CoreDNS. So you can build it from your own repository by just doing Go build or using your CI. So it's really simple since we used or we jumped to Go modules. And also Caddy is looking into like using the Go plugin system because just that's a pain for them as well. So.
Yeah. Right. Okay. Yeah. I think we have another question here. Yeah, it's not ideal, but it is what it is.
So if I got CoreDNS installed in my Kubernetes cluster and I update the CoreDNS plugin with another plugin that I install for CoreDNS, would this give me any downtime in my cluster in terms of DNS?
No, you should be able to. There's a couple of. I'm not sure exactly the scenario you're talking about. But in general, the answer is no. You shouldn't really ever have to have any downtime. So it's completely stateless when it's running in Kubernetes. It's caching everything from the API server. If you kill one of those pods, the other ones will be fine and still serve traffic. I mean, of course, there's some delays based on the kube proxy service
Thank you.
time. But yeah, and if you want to add it, if you update the core file, if you do a new build and you have a new image, new binary, then you're going to create new pods. But if all you do is change the core file, it will just reload it. And as long as you don't screw it up, you'll be OK. If you screw it up, so you should never do it like live on a production system, it will actually reject the reload, and it will continue running just fine. But that persistent volume, or the config volume that's got that config map on it, now has a bad core file. If you kill that pod and a new pod starts up, it's never going to start. So yeah, don't do that. Okay, well, that's not working, but yes, we'll stick with questions then.
Okay, so you said you can use Route 53 in two ways, right? You can either pull the API server or just have it upstream it. If you just upstream it and have like the same cache TTL as your pull rate, is there any advantage, right? Because like you just cache it anyway.
So the question, he did Route 53. So but the question was, if you're using Route 53 plugin, right? You're pulling stuff from the Route 53 API and you're polling it, presumably, occasionally. Yeah. And what's the advantage to that, to just using forward to upstream to Route 53, and they're cached in both cases?
I think the question is about, are you going to use API system, or you want to use DNS system to transport to do the data sync up, right? Okay, yeah. There are several different things. First of all, if you look at DNS, people talk about DNS, say, okay, DNS is old, it's stable, but DNS is actually UDP based. And UDP is not necessarily going to guarantee your reliability. And if you encounter some errors or in the middle of the data transport, you could encounter error that's going to be very hard to track. But for Route 53, the good thing with Route 53's API is that actually AWS API always have HTTPS. So you actually guarantee at least if you see error, you can see the error, like in TCP mode. That's one advantage. Another advantage is the security, right? I mean, certainly if you use DNS, of course, you can use like DNS over TLS to protect your data, but with HTTPS, it's already baked in. Another advantage is that you actually avoid very hard to configure situation when you are in a VPN. You actually want to talk to AWS, but AWS, you also have some firewall rules that's actually preventing certain protocols to traverse through the internet to reach AWS, right? But the good thing with API-based Route 53 plugin is that you don't need to actually get into AWS. You only need to access the API point of AWS, which is actually worldwide available, and you can get the data. Now, if you want to sync the data in a certain VPN or anything, your data is already there. Whether or not the data is exposable to your node in your cluster, that's another question. But at least it avoids you to set up direct communication between your core DNS server and the DNS server on AWS. So you see the difference, right? You actually avoid the direct communication of UDP. That's a good advantage in operational. Yeah.
All right. Any other quick questions? I think we're out of time. But
by the way, just one more thing. It's kind of embarrassing. Somehow I think there's some change in the code of CoreDNS, but I'll try to make sure it works, and I'm going to post that in github.com/CoreDNS/demo and make sure it works all the time. So if you check that.
Thank you.